Okay, so what we're doing right here is we are looking at one of the simple examples of using the quadratic formula to solve an equation. And as you can see right here, this equation is not in standard form. And what we need to do in order to use this is put this in standard form. So remember, that means getting all of our terms over on one side and having our quadratic equal to 0. So in order to do that, we need to get this 13 over on the other side. So the easiest way to do that is just subtract 13 from each side. And what that'll do is that'll leave you with 0 on the right hand side and negative x squared plus 4x minus 13 on this side. Now, one of the common questions I get is it okay to have a negative in front of x squared? That is completely fine. What that's going to do, it's just going to make your a value negative. So once you get it in standard form, you just go ahead and always write down your a, b, and c values. This is really important when plugging your values into the quadratic formula. So you'll see we get a equal to -1, b equal to 4, since that's our coefficient in front of our b term, and c equal to -13, because we have -13. We always include our sign into the value. So plugging these in to your quadratic formula, you get -b, so -4, then plus or minus the square root of b squared, so 4 squared, minus 4a. So notice we've got our a term in parentheses, -1 for a. So minus 4ac, so -13 for c. Notice how here, when we're multiplying 4 times a times c, we put both our a and c terms in parentheses. This helps us keep track of our negatives because here we're multiplying -4 times a times c. And we actually have 3 negative values here. So you're really going to have to keep track of these negatives when you end up distributing -4. So what we have is -4 times -1 times -13. And you'll notice when you work that out, you end up with 16 minus 4 times -1 is +4, and +4 times -13 is -52. So we end up with 16 minus 4 times 13. Oh, I'm sorry, it's minus 52. So 16 minus 52 gives us -36 here, and it's -4 plus or minus the square root of -36. So what we get is we go ahead and we simplify our negative under the radical. Remember that you take your negative out, so you get square root of 36 times the square root of -1. Square root of -1 is I, and you get square root of 36 times I. So you end up with plus or minus 6i, and you get -4 plus or minus 6i. Now, in order to get your two answers to this, you get -4 plus 6i, -4 minus 6i, and the whole thing can be divided by -2. So you end up with 2. -4 divided by -2 is 2, and 6i divided by -3 gives you plus or minus 3i. And you end up breaking that up into two different values because you've got both the plus and minus values. So you get 2 plus 3i and 2 minus 3i. So these end up being your two complex numbers here that are your solutions. 2 plus 3i and 2 minus 3i. The things that I want to point out again are right here when you have -4 plus or minus the root of -36. You have to take this negative out, and that gives you I, and you're left with the square root of +36, which gives you 6i. And right here, you can simplify this because both of the terms in your numerator are divisible by 2. You end up simplifying. You take the 2 out and you get -4 divided by -2 gives you 2, and positive and -6 divided by -2 gives you positive and -3. Because you're dividing by -2 on a plus or minus number, it still stays plus or minus 3i. What you can do is you can plug this into a graph just to check this and see. And like we talked about in class, when you have complex solutions, you're going to have no x-intercepts on this. You'll notice that this graph points down because our a value is negative, and it does not cross the x-axis, again because our solutions are complex.